Welcome to a world where nature's architects outshine human engineers. As we begin our journey into wild builders, incredible animal shelters versus human structures, prepare to be amazed by the ingenuity of creatures great and small. Imagine soaring over the African savanna, where termite mounds rise like skyscrapers, reaching heights of up to 30 feet. These aren't just simple dirt piles, they're intricate structures with complex ventilation systems that put our air conditioning to shame. As we zoom in, you'll see the bustling activity of millions of tiny engineers, each playing a crucial role in maintaining their colossal home. Now, picture a beaver dam so massive it's visible from space. In Alberta, Canada, beavers have constructed a dam stretching over 2,800 feet long and up to 14 feet tall. This isn't just a barrier, it's a thriving ecosystem, a testament to nature's ability to reshape landscapes on a grand scale. You might think you know about animal homes, but we're about to reveal mind-blowing facts that will challenge everything you thought you knew about architecture in the natural world. Did you know that some bird nests can weigh up to 2,000 pounds and last for a century? Or that certain spiders create intricate trapdoors complete with silk hinges? As we explore these incredible animal structures, we'll draw surprising parallels with human architecture. You'll discover how termite mounds have inspired energy-efficient building designs, and how the weaving techniques of birds have influenced our own construction methods. By the end of this video, you'll never look at a bird's nest or a skyscraper the same way again. Get ready to witness nature's architectural marvels and uncover the secrets that could revolutionize our approach to sustainable building. Red foxes are master architects of underground shelters, creating complex den systems called earths that serve multiple purposes. These burrows typically feature tunnels 15 to 20 centimeters in height and 25 to 30 centimeters wide, excavated at a 40 to 45 degree angle. Foxes often construct multiple entrances, including a main entrance and emergency exits, with chambers located between 1 and 3 meters below ground. Interestingly, foxes are adaptable in their den building, sometimes repurposing existing burrows from rabbits or badgers, or even creating unusual nests in unexpected locations like tree crowns. Groundhogs elevate underground architecture to an art form, creating elaborate burrow systems that can extend up to 65 feet in total length. Their architectural design is remarkably sophisticated, featuring a strategic digging pattern that prevents flooding. When constructing a burrow, groundhogs first dig inward, then incline the tunnel upward before proceeding horizontally. Beavers are nature's master engineers, creating impressive aquatic structures that reshape landscapes and ecosystems. Their architectural prowess is evident in the construction of both lodges and dams, which serve as essential components of their habitat. Beaver dams are remarkable structures that can stretch up to 2,800 feet long and reach heights of 14 feet. These industrious rodents begin their construction by diverting the stream to reduce water flow pressure. They then drive branches and logs into the streambed to form a base, followed by an intricate layering of sticks, bark, rocks, mud, grass, and other available materials. Beavers can transport their own weight in building materials, using mudslides and canals to move logs into place. The resulting dam creates a pond that serves multiple purposes, including protection from predators and easier access to food sources. Once the dam has created a sufficiently deep pond, beavers turn their attention to constructing their lodges. These dome-shaped structures are built atop the dam and can be more than 12 meters across and 3 meters high. The construction process is a family affair, with each member contributing to various tasks. Beavers begin by arranging logs in a rough cone shape, then layer other materials, using mud as a binding agent and insulator. The lodge typically features multiple underwater entrances for security and access during icy conditions. Inside, beavers carve out individual chambers, including a nursery, sleeping quarters, and a feeding area. Beaver dam and lodge construction showcases nature's ability to create sustainable, multifunctional structures that adapt to and shape their environment. These aquatic architects demonstrate that effective, eco-friendly building solutions can be found by observing and learning from nature's own engineers. Birds showcase remarkable architectural diversity in their nest construction, adapting their designs to specific climatic conditions and environmental challenges. Cup nests, the most common type in North America, are typically woven from sticks, grasses, and bark, lined with soft materials for comfort. These structures can be found in shrubs, tree forks, or even human-made structures. Pendant nests, on the other hand, are intricate woven structures that dangle from slender tree twigs, providing protection from predators like snakes. Weaver birds are masters of this design, with each species having its unique construction style. Some birds opt for more enclosed designs, such as dome-shaped nests with side entrances. These structures, built by species like lyrebirds and fairy wrens, offer additional protection from solar radiation. The architectural variations extend to materials used, with some nests featuring thick walls while others are nearly transparent. Sphere or ball-shaped nests, often built by sunbirds, are meticulously camouflaged with lichen and moss, held together by spider webs. Great apes, including chimpanzees, gorillas, bonobos, and orangutans, construct nightly sleeping platforms high in the trees. These nests are more than simple resting places, they are complex structures that play a crucial role in the apes' daily lives. The construction process follows a standardized sequence, beginning with the selection of a suitable site, followed by the creation of a foundation using bent and woven branches. The apes then build a circular rim and line the nest with softer materials for comfort. Ape nests serve multiple functions beyond mere sleeping quarters. They provide protection from predators, offer improved thermoregulation, and may even reduce exposure to pathogens. Studies have shown that these arboreal nests can significantly insulate against low ambient temperatures during the night. In cooler conditions, chimpanzees have been observed building thicker nests with more broken branches, likely to enhance insulation. Additionally, when faced with increased rainfall and decreased temperatures, some ape species, like western gorillas, are more likely to construct nests rather than sleep on the ground. The sophistication of ape nest construction suggests a high level of cognitive ability, with some researchers proposing that this skill may be a precursor to tool use. Both wild and captive apes demonstrate a preference for comfortable sleeping arrangements, often choosing softer materials for their night nests. This behavior underscores the importance of quality sleep for these primates and may provide insights into the evolution of nesting behavior among our closest relatives. The earliest human shelters were simple structures made from readily available materials. Around 60,000 years ago, early humans began constructing rudimentary shelters using bones, hides, and tree branches. These primitive dwellings provided basic protection from the elements and predators. As humans developed tools and techniques, they started creating more sophisticated mud and branch huts. These structures often featured a wooden framework filled with clay, offering improved durability and insulation. As human civilization advanced, so did our shelter building techniques. Houses of wood, brick, and stone became prevalent, offering increased durability and comfort. The Industrial Revolution, 1760 to 1840, revolutionized construction, with mass production of iron, bricks, and nails making building easier and faster. Wood-framed houses, when properly constructed, can be incredibly durable and perform well in seismic zones. Meanwhile, brick and stone structures offer excellent longevity and fire resistance, though they may require additional insulation for energy efficiency. In urban areas, apartment buildings of steel, concrete, and glass have become dominant. These structures utilize modern engineering principles to create tall, efficient living spaces. The use of steel and reinforced concrete allows for greater heights and structural stability, while glass facades provide natural light and aesthetic appeal. These materials combine to create buildings that can house hundreds or even thousands of people in a relatively small footprint. The concept of movable shelters has evolved alongside human needs for mobility and flexibility. Tents, one of the oldest forms of portable shelter, continue to be used for both recreational and emergency purposes. Modern tents utilize lightweight, waterproof materials and innovative designs to provide comfortable temporary housing in various environments. Houseboats offer a unique blend of shelter and transportation, allowing people to live on water while maintaining the comforts of a traditional home. These floating dwellings range from simple structures to luxurious floating mansions, adapting to various waterways and lifestyles. Recreational vehicles, RVs, represent the pinnacle of modern movable shelters. These vehicles combine transportation and living space, equipped with amenities like kitchens, bathrooms, and sleeping areas. RVs allow people to travel and live comfortably, embodying the spirit of modern nomadism while providing the comforts of home. The evolution of human shelters reflects our species' remarkable ability to adapt, innovate, and create increasingly sophisticated living spaces. From simple mud huts to towering skyscrapers and mobile homes, our dwellings continue to evolve, meeting the changing needs of human society. Animal architects rely primarily on instinct and inherited knowledge to construct their shelters. Beavers, for instance, instinctively build dams and lodges without formal training. Their designs are remarkably consistent across generations, showcasing the power of innate building skills. In contrast, human architecture involves extensive planning, design, and engineering. Our structures often require years of education and experience to create, resulting in diverse and complex buildings that reflect cultural, aesthetic, and functional considerations. Animals predominantly use natural materials found in their immediate environment. Birds weave nests from twigs, grass, and mud, while beavers utilize branches, stones, and mud for their dams. This approach results in structures that blend seamlessly with their surroundings. Humans, on the other hand, have developed a wide array of manufactured materials like steel, concrete, and glass. These materials allow for greater structural diversity and the creation of towering skyscrapers and expansive bridges. However, this reliance on manufactured materials often leads to environmental concerns and a disconnect from natural ecosystems. Animal shelters demonstrate remarkable adaptability to environmental challenges. For example, termites construct mounds with sophisticated ventilation systems that maintain stable internal temperatures despite external fluctuations. Similarly, beavers adjust their dam designs based on water flow and available materials. This innate ability to respond to environmental conditions ensures the survival and comfort of animal inhabitants. Human architecture has increasingly drawn inspiration from nature's adaptive designs. The concept of biomimicry has led to innovations like the Bosco Verticale in Milan, which incorporates over 900 trees and thousands of plants into its design, helping combat urban smog and increase biodiversity. Another example is the BIQ house in Germany, which uses algae facades to provide shade and generate biogas for power. These innovations showcase how human structures can become more responsive to environmental challenges by emulating nature's time-tested solutions. Termite mounds offer remarkable insights into energy-efficient building design. These structures feature an intricate network of tunnels and chambers, known as the egress complex, which facilitates natural ventilation and climate control. The mound's design allows for continuous air circulation, with hot air rising and being expelled from the top while drawing cooler air from the base. This natural air conditioning system maintains a stable internal temperature despite external fluctuations. Architects and researchers have studied these mounds to develop innovative cooling solutions for human structures. The Eastgate Center in Harare, Zimbabwe, designed by Mick Pierce, exemplifies this biomimetic approach. The building uses low-power fans to circulate cool night air throughout its floors, while concrete slabs absorb heat during the day, resulting in energy savings of up to 35% compared to similar buildings. Animal architects provide valuable lessons in creating sustainable, adaptive structures. Beavers, for instance, demonstrate the use of local, natural materials in constructing dams and lodges that reshape ecosystems. Their ability to adapt their designs based on water flow and available resources offers insights into responsive architecture. The concept of biophilic design, which integrates nature into architectural concepts, draws inspiration from various animal habitats. This approach not only enhances sustainability but also promotes well-being and productivity among occupants. Examples like the Jewel at Changi Airport and Amazon Sphere headquarters showcase how incorporating natural elements can create inspiring and efficient spaces. By studying and applying these natural design principles, architects can create buildings that are not only more energy efficient but also more harmonious with their surroundings. The integration of biomimicry in construction opens up exciting possibilities for sustainable architecture, offering solutions that have been refined by millions of years of evolution. As we wrap up our exploration of wild builders, incredible animal shelters versus human structures, we've uncovered the remarkable ingenuity of nature's architects. From the intricate burrows of foxes and groundhogs to the impressive dams and lodges built by beavers, it's clear that animals have evolved sophisticated building techniques that serve their survival needs. We've also seen how birds create diverse nests and how great apes construct cozy sleeping platforms in the treetops, demonstrating a deep understanding of their environments. Moreover, our comparative analysis highlighted the differences between animal instinct and human planning, showcasing how animals use natural materials and adapt their designs to environmental challenges. We've learned valuable lessons from these wild builders, particularly in terms of efficiency in design and sustainable building practices inspired by nature. The principles of biomimicry remind us that by observing and learning from the natural world, we can create more efficient, sustainable, and harmonious living spaces. As we move forward, let's embrace the wisdom of nature in our architectural endeavors. Whether you're an architect, a designer, or simply someone who appreciates the beauty of both nature and human ingenuity, consider how you can incorporate these lessons into your own projects or daily life. If you enjoyed this journey into the world of wild builders and want to learn more about the fascinating intersections between nature and architecture, don't forget to like this video, subscribe to our channel, and share your thoughts in the comments below. Together, let's continue to explore the wonders of our natural world.